let's begin. Happy Monday, week 4 Monday, and today we will take a look at data wrangling with dplyr. A lot of my stuff is based on the R for Data Science textbook. Apparently now there's a second edition available online, so you should probably go with the latest edition. And I did not explicitly link it, but Friday's lecture was on tidyr, and there's a chapter in chapter 6. Chapter 6 is data tidying. Okay, so use that as a reference. And then today we are looking at dplyr, which corresponds to chapter 4, data transformation. And I know I'm going in a different order from the textbook here, but I think that's okay. The whole textbook's really good. So as you have free time, that was a joke. Read through what you're able and use it as a reference. And as when you have a project and you want to do stuff, look at the things. A lot of tools are available to help you do what you want to do. All right, so we're going to take a look at dplyr. Dplyr is its own package, and it can be loaded by itself. And you can load it with library dplyr, or you can load library tidyverse. And dplyr is a core part of the tidyverse, and so when you call up tidyverse, it will load dplyr along with a bunch of other packages like ggplot and tidyr and readr and all of these other things. So that's that. A lot of this comes from the dplyr vignette, as well as that chapter in the textbook. And it says, this is kind of how dplyr will help you. It's true that dplyr doesn't necessarily bring anything brand new to the table that R wasn't capable of doing before. So, you might have learned like how to use tapply, and you know how to subset things, and you know how to do all of these different stuff. But I do believe dplyr gives us kind of this language that allows us to work with data in a little bit more of a faster and efficient way. And I found that I am made much more effective by using dplyr than without it. Okay, and so it says, when working with data, you got to figure out what you want to do, and then put those ideas into a computer language or computer program, and then you execute the program. And dplyr helps us do this by kind of giving us a set of verbs. It says it constrains our options, and those verbs, basically each one does like one specific job, and you can kind of like chain them together or link them or pipe them together, and with that you can pretty much accomplish almost everything you need to do, especially if you pair it with the tidyr verbs, where you can take your data and then pivot them wider or pivot them longer. With that, also in your toolkit for things to do, there is quite a lot that you can do. So let's take a look at these verbs that we're going to be using, and we will look at these ones: select, filter, mutate, arrange, summarize, along with group by. And there's other verbs in dplyr, such as distinct and slice and whatnot, that you can look up more information about. Search the help, read the textbook for more information. But these are going to be kind of your primary tools. And basically, you have select. Select will pick columns. Filter will pick rows. So we use select to pick columns or variables based on their names. Filter we use to pick rows or cases based on their values. We have other functions. Mutate will create new variables. And arrange will take our results and basically arrange them or sort them in a way that we like. Summarize will take a bunch of rows or information from many rows and summarize them down into basically one set of values, which is what summary functions do. And then summarize and actually all of the functions will pair with group by. I'm going to be throwing a lot of information at you in this lecture, and I don't expect everybody to absorb everything in one sitting and one go. But I guess I want this lecture to be kind of like, at least like, hey, here's a feature that's available. And then as you kind of work through stuff, you'll be like, oh, I think I remember hearing about this, and then you'll want to look it up and things like that, right? I have little like mini examples that are just very, very concise that kind of show a little bit of how they do, but they're not like super in-depth and whatnot, right? I'm trying to cover a whole bunch of stuff within our 50-minute time window, okay? Another very helpful resource as you're working with dplyr is the dplyr cheat sheet. There's an updated version of this, different from the screenshots that I have, but this is the dplyr cheat sheet. It looks almost the same, except they changed the name of the company from RStudio to Posit. Posit is now the company. Their product is RStudio. I guess it's a little bit like Meta is the company and their product is Facebook or something, or whatever you want to. I guess. Okay, that's not a good example because Posit is a great company. So we're going to be looking at the Star Wars data set as an example here. The Star Wars data set contains information about characters from the Star Wars movies. This data set was created after The Force Awakens, but before, what were the other ones? Last Jedi and Rise of Skywalker or something, whatever. Okay, so the 7 movies in the 7 out of the 9 movies in the Skywalker saga, not including the spin-offs. I don't know if we have Star Wars fans here, and if I'm just talking gibberish, I'm like semi into it. So, or maybe more into it than I should admit. But anyway, we have so we have Luke Skywalker, height 172 centimeters, mass 77 kilos. They use the metric system in Star Wars, I guess. And blonde hair, fair skin color, blue eyes, birth year 19. So Star Wars, it's years before the Battle of Yavin, which is where the Death Star blows up at the end of the 4th episode, but first movie chronologically. And I guess Luke was 19 at the time. And then we have these other variables. And then again, this is a tibble, and so the variables that don't fit, films, vehicles, and starships, get just kind of listed over here, and it says there's 77 more rows. There's 87 named characters in this data set. So we can take this data frame, or this tibble Star Wars, and we can say, from this data frame, which has 14 columns, so it says 87 rows, 14 columns, maybe I only want to select 4 columns. I only want to select the name of the character, their home world, what species they are, and what films they appear in. And so we do that, and we say select, and we're going to select from the data frame Star Wars these 4 columns: name, home world, species, films. You don't actually need to even put quotes around the variable names, as long as they kind of follow traditional variable naming conventions, which would be like no spaces, don't start off with a number, things like that. So we can do that. And then so we see Luke Skywalker, Tatooine, human, and at the time of this data set's creation, he had this character appeared in 5 films. 3 in the original trilogy, 1, Revenge of the Sith as a baby, and at the very, very end of Force Awakens, right? So 5 films, and then you have C-3PO, who had appeared in 6 of the films, R2-D2 and 7, okay, and things like that. So you have all of this information here, okay? from here on out, I'm going to be showing our commands by using pipes. And so here we used select, and the first argument is the name of the data frame that you're dealing with, or that you're working with. And instead of writing select from Star Wars, name, homeward, species, films, I'm going to do Star Wars, and then this is what we call the pipe, and we pipe that into select, and this effectively takes this, whatever it gets piped in, and puts it into the first argument here. So basically we're saying from Star Wars, select name, homeworld, species, and film. Okay, and so you're going to see this this character, and so these two commands, this and this, are exactly the same. They but this one uses the pipe, and this is how I'm going to be showing the creation of our commands. And I like it because it kind of shows this sequential nature. You know, first we're going to start off with the data frame, then we do this operation, and then you can pipe that result into the next command, and we're going to do another operation, and you pipe that result into another command, and you do another operation. You kind of have this sequential flow of, you know, operations that we're doing. As you work in R and you want to insert the pipe, you don't have to always type in % greater than %. I mean, you can, and that will work, but there is a keyboard shortcut, and that is Control or Command Shift M. And that will insert the pipe for you. So let's take a look at a few examples here. First, we can, you know, you can give the names, but you can also put negative signs in front of the names if you just want to select everything but a few columns. So we can say select and then minus sign, name, eye color, minus birth year, and basically we will not select those columns, and this is the resulting data frame that we get. Okay. You can also use colon, all right, and so you can say I want all the columns name through eye color, all right, and these I've been piping into head, so I just get kind of like the top 3 rows from the data frame. So from Star Wars, select the variables name through eye color, which are these variables, and then select the top 3 from there. dplyr comes with these select helpers, okay? And so you can look up more information using this command, tidy select, : select helpers. And these allow you to select certain column names, okay, columns based on their names. And so, you know, sometimes you're going to be working with a huge data set, okay? Maybe a data set with like 200 columns. And the columns might be inconveniently named, right? It might be like one column is like FY 2022 Q1 or something, right? Like fiscal year 2022 quarter 1, fiscal year 2022 quarter 2, and stuff like that. And it can become like a little bit annoying having to deal with, you know, all of these column names and whatnot. And so these are tools that can help you select some of the columns based on their names, right? And so we have contains, starts with, ends with, matches, everything, numeric range, one of. Numeric range is used for columns named something like x1, x2, x3, x4, x5. And basically any of these things, you can always look up the help associated with these things for a little bit more details. Here's a couple examples. So here I can say I want to select the columns, okay? I want to select the name column along with any column that ends with color, okay? And so I get name, hair color, skin color, eye color, right? So that's a way for us to select multiple columns just based on the column name. This is a regular expression, okay? $$ is a regular expression for expressing ends with the character S. Now, we already have ends with, so I could have just done ends with S, and it would have been exactly equivalent. But with regular expressions, you can do like very complicated text matching type of stuff. And so if you wanted to give it a more complicated regular expression, you can do that. But here's a simple one where $$ basically says I want variable names that end with an S. And so we get name along with mass, species, films, vehicles, and starships for for the variables that we end up selecting. This seems a little bit silly. There's a command called all of, and here I have this vector called vars, and it's a character vector with the names name, mass, and height. And I can say select all of vars, and I select the variables name, mass, and height. And you might wonder, like, why would we ever want to do this, right? Why wouldn't I just say select name, mass, and height if I'm going to type them out here and put them into this thing vars and then write select all of vars, okay? Well, you probably wouldn't run code like this. This is a little bit silly. But you can imagine a different scenario where you have separate code where, I don't know, you iterate through stuff, and in that code, in that for loop or something, you're creating a new vector, and that vector contains variable names, right? So you can imagine doing some kind of operation where you're going through stuff, and then you're saving information, and that information is going into a vector, and that vector contains variable names. And now you want to select values based on the values in that vector that you just created. So in that case, this is going to work because you might not know exactly what characters are going to show up into this vector, and so you just say select all of whatever shows up in this vector that you created somewhere else. Okay, so this thing where you're going to like type out these things and then do this, that doesn't make sense. But you have the flexibility of creating this vector somewhere else in your code and then using that to select columns. Okay, so that's select. Let me go ahead and give you your first view quiz answer for today, which is the letter B. B as in bear. B as in bear is your first view quiz answer, B. Okay, let's look at the next verb, filter. So select will select columns. Filter will select filter rows, okay? We do filter to kind of filter which cases, which rows we want using some kind of logical condition. All right, so one of the most basic kind of things we can do is we write name equals R2D2, right? And so this is a logical comparison, and we want to know, is name equal to R2D2? And it's going to basically be false for everybody except for the one row where the name is R2D2, and so we filter out that row and we get this one, we get the one character R2D2, okay? So that's filter, name, and you can do equals, and that's an operation, right? So you need a logical vector that with length equal to the number of rows. Here's another example. You can have multiple conditions. So here I said select filter species in percent human droid and height under 175. So we're going to get species has to be human or droid, and height also has to be less than 175. Okay, so this will filter out Darth Vader, who's too tall. Okay, and it's going to filter out any character who's not human or droid. Now, it's important, and you might want to indicate this to yourself in your notes. Use the % operator, okay, if you want to see is species human or droid, okay? Do not use species equals human droid, okay? Why would we not use equals, okay? Well, what happens if you do species equals vector human comma droid, well, R sees that as a test for equality, and then you have the human droid thing, and it's going to recycle that vector. So it's going to do row 1, is that equal to human? Row 2, is that equal to droid? Row 3, is that equal to human? Row 4, is that equal to droid? Row 5, is that equal to human? Row 6, is that equal to droid? And it's going to recycle human, droid, and it's only going to return matches if like the odd ones are humans or the even ones are droids, and if you have a human in an even row, it's not going to match, okay? And so you need to do the % in %, and it's going to check is it human or droid in those things. You could alternatively do species equals human, vertical bar, or species equals droid. That would work. But this is just a more efficient way to do it, okay? Species % in %, human, droid, and whatever else you want to do. So don't use equals. if you need to check for kind of multiple of these things. Okay. Filter is also very powerful with regular expressions. So there is a regular expression command called string detect. String detect will return true or false if it is able to detect a particular regular expression. So this is a very simple regular expression that says it starts with the character F, but we could, later on this week we will learn regular expressions and more advanced stuff, okay? And you can pair this up, and you can kind of work with text stuff by taking into account regular expressions and filter certain rows and whatnot. Okay. All right. So here is an example of piping results. Okay. So here I'm going to do Star Wars, and we're going to filter. And we're going to say hair color is none, equal to none, or eye color equal to black, okay? And so we're going to get characters where their hair color is equal to none, and if that's not the case, we're going to make sure their eye color is equal to black, okay? And then after that, after filtering, we pipe those results, okay? And from there, we're only going to select the 5 columns: name, species, homeworld, hair color, and eye color. And so we get Darth Vader, human, from Tatooine, and hair color is none, eye color is yellow. And, we got Greedo and, I don't know, these other characters. Okay, so we have that. We can arrange our rows, so whatever result you have, sometimes you want to just look at the top 5 or the ones with the biggest this or the smallest that. Okay, so here we're going to just not apply any kind of filter, but we're just going to say, okay, select these variables: name, birth year, height, and mass, and then let's arrange them in descending order of birth year. Okay, so if I did arrange birth year, then it would go in ascending order, and then here I'm doing descending order, right? So I just wrapped birth year in descending order. And then I give it, and I say if there's a tie, break the tie with mass. So we get Yoda is the oldest character in the named character in the Star Wars universe, 896 years old at the time of the battle, born 896 years before the Battle of Yavin. This is based on a little bit of a throwaway line on, I think, in Empire Strikes Back, where he's having a conversation and he says, when you're... I can't do Yoda speak, but he's like, effectively, like, when you're 900 years old, you're not going to look as good as I do. And apparently Empire Strikes Back takes place 4 years after the Battle of Yavin, and they're like, oh, okay, if he's exactly 900 years old at that time, he was born in year 896 or something ridiculous like that, right? And so that's what we have, okay? And so here is where mass makes a difference. We have these 2 characters, Ki Adi Mundi and Qui-Gon Jinn, both born in year 92 before Yavin, and but the tie is broken based on their mass. Okay, and mass is in ascending order, and so that's how it goes as far as sort. You can select rows using a tool called slice. Okay, and this selects based on position. So slice 5 through 10 says I want to select rows 5 through 10, okay? So that can be handy if you just want to select, a particular row. If if the rows exist in a certain order or something, and you can do like arrange, and then I want the 10th largest for whatever reason, okay? You can do something like that, slice. Another useful function is slice sample. So a lot of times as you're working with your data set, you kind of want to just like take a peek and see like, am I getting what I want to get, okay? And a lot of times we just use head, right? So you'll say like, okay, here's the thing I'm working on. I just kind of want to peek and see, is it working? And then I take and I say, okay, let's put it into head, and it prints out like the top 6 rows, okay? And that's pretty good. Except sometimes, and I don't know if you've encountered this, but you use head, and the first 6 rows look good, and you go, okay, this seems good, and you keep going, and then when you do it, when you look at your entire data set, you realize like, okay, actually only the first 30 rows were good, and then like rows 31 through 80, like something went wrong, and like you didn't notice this because you were only looking at like the first 6 rows. So one thing that you can help avoid that, and again, it's not guaranteed to because it's random, is you can do slice sample. Okay, you do slice sample n equals 10 or something, and it's going to select 10 random rows from your data set. Okay, so it's going to select 10 rows at random, and chances are a little bit better that if all 10 randomly selected rows look good, there's better chances that your data set looks good, right? And again, not guaranteed. There could be, you could have just by random chance selected 10 good rows and there's a whole bunch of other bad rows or something like that. But, by selecting a random sample of 10 rather than just always the top 6 or top 10 rows, you're going to get a little bit of a better, feel for the entire spectrum of the data. And so slice sample can be handy there. I didn't put this in the notes here because it doesn't work as far as RMD goes. But when you're working with R in kind of this interactive mode, one of the a useful function is capital V view. Okay, so here I can do. Let's load up data Star Wars. I already have the tidyverse loaded. Okay, and there's a function capital V view. Capital V view only works in interactive mode in RStudio. You can't put it in as part of your RMD files or something like that. Okay, so I can say, let's do Star Wars. Let's filter, I don't know, mass less than 100, and let's select name through eye color or something like that. Okay. And I can do this, and this gives me kind of the top 10 rows here, okay? And it says there's 39 more rows. What I can do is I can take this and I can pipe it into the function capital V view, and what this will do is it will throw this up here into the viewer, and I can actually see all 49 rows, not just the top 10. And I can, if you have a whole bunch of columns, you can actually, oops, I don't want to do that. You can actually see those as well. So, if I don't do, here, let's do select name and ends with an S, okay? I get these columns back, all right? And I can, kind of scroll through and see the actual results, okay? And so you can actually, here we see a little example where you can actually see the names of the films, or like vectors being stored into each of these cells here. But capital V view is useful as far as, you want to take a look, right? Sometimes you want to create new variables, or you want to just kind of make sure that what you're doing is working properly, and you can do capital V view. It doesn't even create a new object in the environment, and you'll see this doesn't even have a name. The name is dot, okay, to kind of indicate that this is just the whatever gets piped into here. So we're just taking a look at the result, and that is the thing. So capital V view is a very useful kind of tool as far as interactive mode goes. Here is another couple more useful functions: slice min and slice max. Slice min or slice max is kind of like arranging your data and sorting them based on a variable, and then selecting only the top few, right? So it's not actually necessary, but it's just kind of like a handy little feature, right? So if you wanted to say, I want to select the 3 most massive characters, you could do arrange descending order by mass, and then head 3, or slice 1:3. Here you can just do slice max using the variable mass, and then I want the top 3. Okay, and that will do the same thing. So it's the same as doing arrange, and then that. Let me give you your second view quiz answer. Second view quiz answer is the letter E, E as an elephant. E as an elephant is our second view quiz answer. Sometimes you need to create new variables, and we do that using the function mutate. So here I'm going to take height, currently in centimeters, and we want to go to imperial units, American units, I guess, and we're going to take height, divide by 2.54 to get the number of inches, and so I'm going to do mutate height, and I guess Star Wars they use metric system. Okay, so we have height underscore inches, and we're going to do height divided by 2.54. When you use mutate, it always creates the new variable at the very end, the rightmost variable of the data set. So in this case, we can't even see the result of it if I have all 15 variables selected. So from after mutating, I'm going to pipe the result, and I'm going to say I want to select the name, the height, and height in inches. And so now I get Luke Skywalker, 172 centimeters equal to 67.7 inches. When you use mutate, you're creating a new column, so you need to have a value for every single row, okay? And so you generally, I mean, maybe this is what you want, but you generally don't want to use a summary function would say mutate, okay? So if I did mutate, I probably don't want to just say like mean height is equal to mean of height, na.rm equals true, all right? And then I'm going to go ahead and pipe that into view. Because if I do that, you'll notice, what do I have for mean height? I have the mean of everybody, 174.358, but this is going to be the same value that gets repeated for every single person, okay? And is that really what I wanted to do? I mean, maybe, but probably not, okay? You generally don't want to put into your data set, right, a variable that doesn't vary, okay? Because if every single person has 174.358, it's not a variable, it's just a constant for everybody, right? You might as well just keep that separate outside of your data set, so you don't really need to have this as a new column here. So you don't want to use mutate for summary values, okay? But you can use it for, there's something called cumulative mean, which might be what you want. In this case, it's probably not actually useful. Cumulative mean is basically like your running mean so far of the values we've seen so far. What is the mean of the values we've seen so far? So it'd be like, first value is 77, so our cumulative mean is 77. The next value is 75, so we have seen 77 and 75. Our cumulative mean so far is 76. The next value we see is 32. So between 77, 75, and 32, the cumulative mean is 61.3. Then we see 136, and our cumulative mean is now 80, and so on and so forth. These values aren't arranged in any kind of order, so the cumulative mean is probably useless. But if you have some kind of time series information, cumulative mean is a little bit more useful and things like that. Okay, here's a bunch more these are what we call window functions. These are all functions that would produce a value for every single row. So you have pmin, pmax element, wise min and max, cumulative min, cumulative max, cumulative sum, cumulative product, between, which will return logical values, lead and lag, which copy the values with an offset, and then entile. And so here's some examples of just some of these functions being used. And again, it doesn't really make sense to apply it to this data set. But so the cumulative min is kind of like, world record so far is like, what is the smallest mass we've seen? So first value is 77, so that's our minimum so far. Then we see 75, and that's the minimum so far. And then 32 is the lowest we've seen so far, and then we see 136, and so the lowest we've seen so far is 32, and it keeps going, right? So it's kind of like, what's the world record race time, okay? That's basically a cumulative min function, right? What's the lowest time we've seen so far, and then we only kind of change it if we get a new value that's even lower than anything else we've ever seen before, okay? Here I have mass divided by mean of mass, okay? And so this mass mean mass is going to be that, a constant for all the values in the entire data set. So it's the same value. And then here I'm going to do ratio. Okay. So I don't know what the true value is. Maybe it's something around 100-ish. Okay. And we do 90 something ish. Okay. 77 divided by whatever the mean of everybody, we get 0.791. 75 divided by whatever it is, get 0.771, so on and so forth. Okay, p-min gives you element-wise minimum. So you basically compare columns and you say, between these columns, which one's the what's the minimum value we've seen, okay? And you can put in multiple columns. In here, I just put in 2. And again, it doesn't make sense for this example, but where I'm saying, take the column mass, take the column birth year, what's the smallest number? So between 77 and 19, 19 is the smaller number. Between 75 and 112, 75 is the smaller number. 32 and 33, 32 is the smaller number. 136 and 41.9, 41.9 is the smaller number, okay? None of these things actually make sense as far as like why you would do this. It would probably make a little bit more sense if you had kind of different columns representing I don't know. You know, each row is kind of like a score, and you have a column for like each of the states or something, and you can say like if you have it arranged, and you can say, okay, which column is the smallest here? Okay. Lag takes basically one of the columns. So here I took this column mass year p min, and I lagged it by 2. So just copies this column and then offsets it by 2, okay? And so you can see we get NAs for the first 2, and then this entire column gets copied. Or you can do lead, and it copies it, offsets it in the opposite direction. Okay, again, it doesn't really make sense for this example, but it would make sense for something like time series data, where you have an entry for every single month, and you want to compare it to, say, 12 months ago, right? So then you can do a lag by 12 or a lead by 12, and you can say, okay, here's the consumer price index now, here's the consumer price index 12 months ago, and therefore our year-over-year inflation index is this and that, or something like that, okay? Lead and lag. Okay, let's talk summarize. So the whole point of summary functions is to reduce the amount of data that we have to deal with, okay? When you ask, give me a summary of the movie, you're saying, I don't want to watch the entire movie, I just want to know like the key pieces of information, okay? When you're saying, give me a summary of the data, you don't want to know all of the little pieces of information, you just want a single number to summarize it, okay? And you can ask for, I want the mean, I want the median, I want the standard deviation, I want the variance, I want this or that, the min, the max, and they give you each little different aspects of the data without you having to know every single value, right? So the whole point of a summary function is we take a whole bunch of rows and we get down to one row, okay? So that's important to remember. Anytime you use summarize, it's going to compress it down to one row, okay? So, for example, as much as we hate it, your GPA is a summary function, right? And it allows you to, like, if you needed to make comparisons between applicants or something, rather than having to look at their entire transcript and know every single thing, and they got an A in physics but a B in biology, and this and that, and they did well in this class but not in that class, you can just say, oh, GPA 3.72, okay? Compare that to this candidate GPA, 2.85 or whatever, and it is by definition reductive, okay? But it can be useful having summaries, okay? And so here I'm saying, okay, select the column's height and mass. We're going to calculate these summary values. So we're going to calculate the mean of the height, variance of the height, mean of the mass, minimum of the height, maximum of the mass. Also just count how many values we have, also counts as a summary, okay? And these are the values that we get, okay? Summarize is often made more powerful when we pair it with group by. If you use group by all by itself, it doesn't seem like you're doing much, okay? So here if I take Star Wars and I say group by, I get basically back all 87 rows, and it just has this little annotation that says, oh, we have 38 species. So we're going to do create groups by group by, and then we're going to pair that with summarise. So group by and summarise is very, very similar to using a t-apply. So if you guys remember t-apply from stats 20, you can apply like the mean function, and then according to basically a table created by some kind of other variable. But here we can do this with summarise and group by, and I hope we're starting to be able to read my code here. And that I'm starting off with Star Wars. We're going to group by species. I guess there's 38 different species represented in this data. From there, we're going to select the variables name, height, mass, and species. And after that, we're going to calculate these summary values. We're going to get the mean height, the standard deviation of the height, the mean mass, standard deviation of the mass, and then get a count of how many values got summarized. And so the first entry is the Alina species. I don't know what movie that's from or who that is. Height was 79, mass was 15, and because there's only one individual, there's no standard deviation, okay? We have droids, and we had 6 named droids in the data set. The mean is 131, the standard deviation is 49, mean is 69.8, and the standard deviation is 51. So high variance in the droids there. And that's what we have. Now, this is fine. Okay, I have 38 rows because we have 38 different species. So we get 1 row for each of the groups we've created. I can further take this and I can filter that, right? So I can take this resulting table, and then I can do more dplyr operations on this resulting table. So I can say, take that resulting table and filter it so I only have rows where the count is greater than 1. Okay, so now we have 6 different species represented. And then I want to arrange the resulting table in descending order by count. And actually I don't know how many we have, but I'm only looking at the head, the top 6. So we have humans with a mean height of 177 and a standard deviation 12.5, a mean of 82.8 and a standard deviation 19.4, and we have 34 of them. Droids and unknown species, Gungans, Kaminoans, whatever, okay? And this is what we have, okay? And so that's what we have there, okay? You can use group by with other examples. I would say group by summarise. This is probably the most important kind of combination that you'll have, but you can also use group by with other variables. So here's group by used with mutate. And so here I'm going to take Star Wars. I'm going to filter. I only want species that are humans or droids, or species is missing. I'm going to select name, species, height. We're going to group by species here. And then I'm going to calculate z-scores. I'm going to do height divided by minus the mean divided by the standard deviation. Okay? And so we know z-scores are positive if the person's above the mean, z-scores are negative when they're below the mean. And because I did a group by, the z-scores, the mean, and the heights are calculated according to the grouped species. Okay? So you'll notice Luke Skywalker is taller than C-3PO. Luke Skywalker has a height of 172. C-3PO has a height of 167. But Luke Skywalker's z-score is negative because he is below the mean height of all humans. C-3PO's z-score is positive because C-3PO is tall for a droid. Okay, so his z-score is positive. It's greater than the average. Okay, so these z-scores are calculated using the group by. What I can do is I can remove the group by thing. Okay, and so here, if I remove group by, then the mean and the standard deviation are calculated for the entire data set, not by groups. And so now Luke Skywalker, who is taller than C-3PO, Luke Skywalker has a positive z-score, and C-3PO has a negative z-score. Okay, and that makes more sense because this makes sense because they are now being compared to the entire set of all humans and droids. Versus over here, it was calculated by groups. You'll notice one stylistic choice when I write my code is I put each verb on its own line. Okay, and this allows me to kind of just remove operations line by line if I wanted to. I can just comment out that one line and it removes that one operation. So I kind of recommend that. You put each verb on its own line, and then if you need to comment out a certain verb or action, you just comment out that one verb. Here's a little bit more examples of group by. And let me give you your third view quiz answer. Third view quiz answer is A. A as an apple. A as an apple is your third view quiz answer. All right, so here's just some toy data. I've got 12 rows in it, and we've got Afghanistan, 1999, female. We've got 3 countries, Afghanistan, Brazil, China, year 1999 and 2000 for all 3 countries, and then we have male and female, one for each year, and then just some fictional numbers, 11111, 2222, and 3333, okay? And what we're gonna do is we're gonna take this kind of toy fictional data, and we will do group by, and we're gonna use 2 columns. So here I'm gonna do group by country and then year. Group by country and then year, and then we're gonna say sum the cases. So when we group by country and year, we have 6 groups. Afghanistan 99, Afghanistan 2000, Brazil 99, Brazil 2000, China 99, China 2000, and then the sums sum up the corresponding numbers. Because we've grouped at 2 levels, country and year, there is still another grouping hierarchy. We still have groups by country, Afghanistan, Brazil, and China. And so I could take this result, summary 1, and then further summarize that, and then we will get a row for Afghanistan, a row for Brazil, a row for China, A, B, C, and then I can further summarize that, and then now everything gets put into one line. So that is group by country, then year. What would happen if I group by year, then country? Okay, year, then country. Notice we still have 6 rows, but this time they are arranged by year first and then by country. So we have year 1999, year 2000. Within 99, we have Afghanistan, Brazil, China. Within 2000, we have Afghanistan, Brazil, China. Okay, and then within here, there's a hierarchy of groups. So we have group for the year. And so if I apply summarise here, then I get a row for 99, and then I get a row for 2000. And then if I apply summarise there, then it boils all down to 24 again. Okay, so I hope these 2 slightly different examples, grouping by country then year versus grouping by year and then country, that difference makes sense. Okay, all right, I'm gonna run out of time here, but I just want to go very quickly over joins. Okay, so joins allow you to kind of combine 2 different tables based on some kind of matching criteria. So I have 2 very simple tables. A table called people. I've got A, B, C, D, Adam, Betty, Carl, Doug, and the states are CA, CA, NY, and TX. And then we have a table for states that I guess show us the abbreviations, and we got CA, NY, WA, California, New York, Washington. Okay. Now I intentionally have a mismatch between the states and the abbreviations to kind of illustrate the different kinds of joins. So imagine a Venn diagram, right? You got one table on one circle, another table for the other circle. The left join is basically one of the circles in the Venn diagram. So you have people left joined with states. We are going to keep all the rows in people, A, B, C, D, Adam, Betty, Carl, Doug, California, or CA, CA, NY, TX, and then so we keep all the rows on the left table, and we only pull matches from the right table, okay? So we get TX, and there's no match in the state name, so we get an NA here. The right join works in the opposite way, okay? It keeps the other circle. It says keep everything on the right side table, states, so we have CA, NY, and WA, and then only pull the rows that match on the people. The inner join is the intersection. So we only keep rows where we have full matches. Okay, so we only have Adam, Betty, Carl, and California, New York, which match. And then the full join is like the union, and we're going to keep all the rows in the people table along with all the rows in the states table. And we have NAs where they don't match. Okay, and that is kind of how the 2 table, the inner joins and the left joins and the right joins work, okay, or full joins. And then depending on what columns you have in common, you might have to specify how how the columns get matched. So here, you know, we matched the column called state with the column called abbreviation there. Okay, that's it for today's lecture. It was kind of a lot of stuff, so you know, make sure you take your time to kind of review this and go over it, and I hope you guys do well. We will see you on Wednesday.